Hi, so in this video, we're going to look at different kinds of UMG container widgets and their different layout and scaling behaviors. This is a pretty important area to cover before we start building anything because it's going to make what I do later on make much more sense. So, to start with, the basic container you end up with by default when you create a new widget is a canvas panel. Now, you don't have to use a canvas panel as your root. You can replace it with any of these other panel types. These are just your basic panel types. So we could change it out for a vertical box or change it out for a grid panel. And this replace with dialog can be pretty handy. It can be used on any widget if you decide that you want to swap around your widget types within a tree and it won't disturb any of the other widgets around it. So to start with, I'm going to go back to the canvas panel because in a way it's the most complicated of the container panels, so we're going to get that one out of the way first. So to start with, I'm just going to drop a border onto our canvas panel, and a border is just a basic sizable rectangle. It has a background color, which is this brush color here. So I'm just going to paint this one red. And it can also take a child, which makes it useful for placing things such as text or images in a basic container. So this is our basic border that we're going to use here. And I'm going to use it to explain the properties of a canvas. So if you have an element placed on a canvas, you will notice you've got two sets of handles around your widget element. You've got your little round handles here, which will surround your element regardless of how it's placed or sized. But you've also got this big sort of ray-shaped handle here. And to avoid confusion, I'm going to refer to these ones as handles and these ones as anchor points, because that's what these guys here are for. This is for anchor sizing, and these are for your standard sort of absolute pixel sizing. And the two different methods of sizing and anchoring are what can make a canvas a bit complicated to work with. Anchors deal in proportional size, so they work based on a percentage of the canvas size. Now you'll see currently dragging these handles around doesn't do anything to the size or placement of our border. That's because unless we hold down Control whilst dragging these, which provides an instant update function, these values will change. But if you want your child layout to match the layout of the anchors, you have to make sure you haven't got any offsets set up here. So, holding down Control is one way of making your child fit into its anchored layout. The other is to go with one of these preset anchor layouts, hold down Control and Shift, and click one of these. Now, you'll see that all of our anchors have moved. They've moved together into a single point now. And this is one of the potential behaviours of something anchored inside a canvas. With a behaviour like this, where all of your anchor points are gathered together and not surrounding your widget in any way, this just anchors the centre pivot point of your child widget. So if I hold down Control and drag this around, you'll see that it just moves my whole widget without affecting its size or its aspect ratio. Right now, its position is being set by our central anchor point, but its size is being set by its handles. This would be different if, occupying the same space, I dragged out its handles to define the corners of the image. While these look pretty similar in the editor, when we come to play, there will be a slightly different behaviour between the two. This will always occupy the same proportion, as you can see here by the percentage values when we mouse over it, of its parent container. Whereas, if we go back to a centered version, this will always remain the same in pixel size. So, if we were on a very small screen, this would render far bigger than the screen itself, it would overlap. Whereas, if it was back down in this configuration, it would shrink down to fit the middle of the screen as defined by these percentage anchor points. You can also mix the two systems in this case. So you would have, in this case, the widget height would be determined entirely by its anchors, and then you would have a fixed size offset at the left and the right of the value that we have dragged this out to. So let's see, we're going to bring them out to 370, 380, it doesn't really matter just now. This area and this height will be proportional sized, whereas this width, your offset width, will remain fixed at pixel size regardless of the screen size. These two scaling behaviours are interesting when it comes to defining how you want your individual widgets to behave on different sized screens, and knowing which of these to choose or how to mix them in some circumstances can inform you on what kind of layout containers you want to use for your widget overall. So that covers the basics of the canvas, and thankfully that's the most complex of our widget containers. If I remove that one, we can move on down to the next of our widget panels, and that is the grid panel. Now there's actually two different variants of the grid panel. They've only got one significant difference, so I'll run through them both together. Grid panel, you can set in proportional sizing how many spaces in your column fill or your row fill you want a particular element to fit. Uniform grid panel behaves similarly, but as you might guess, everything inside a uniform panel will be sized the same. There's no allowing a particular widget to take 2 column slots or 2 row slots. They will all be sized uniformly. So, if we go with the grid panel, it's a pretty simple layout. I'm just going to drop a few buttons in here. There we go. And when you click on one of the child widgets of the grid panel, you get this arrangement up here, which allows you to set its row span, column, and column span, all of which fairly straightforward. So if we start setting some data on these, so right now we have a rather neat little 2x2 grid of buttons. Now, To determine how many rows your grid panel has overall, if you select it in your widget tree, you'll get this panel. So, remembering that these are counted by programming rules, so your numbering will start at 0 rather than 1. I'm going to say that overall, our grid has 2 rows and 2 columns, each of which fills equal space, so at a ratio of 1 to 1. And that fills out our buttons at the desired ratio. If we wanted to make some of them slightly different, we can change the ratios here and they will update as appropriate. Things inside a grid panel will either be center aligned, left aligned, or right aligned, or they will fill on the horizontal, and again they can be center, top, bottom, or fill on the vertical. So those are your alignment options for within a grid. Generally you probably want to make them fill in both directions, and that is the default behavior. That pretty much covers the grid layout. The other useful pair I want to cover here is the horizontal and vertical box. These two have the exact same behaviors, except that one runs horizontally and one runs vertically, so again I'm going to run through those together. With these, I'm going to use a border again, and when you drop some things into them, you'll notice that they get very small and squashed up together, because right now their settings are auto size, and if a widget doesn't declare a specific desired size that it wants to be, its auto size will be very small. So instead, we're going to set their fill mode to fill, and now the available space is filled evenly across the horizontal by the widgets that we've set in here. And you can see if I change one, the others will stretch to fill the available space. This particular layout is also where the spacer comes in handy. This is just a blank space. But say you wanted something in a horizontal box to be right aligned, you have to place a spacer to its left and use the spacer to push it to the position you want it to go in. So this is pushing our border right the way over to the right, because our spacer is set to fill and our border is set to auto size. So this particular behavior would make sure that whatever's inside the horizontal box always sticks on the right. You can do the exact same thing to make something stick at the top or bottom of the vertical box. These are nice for just arranging simple parts of widgets like lists. Scroll box behaves pretty much exactly the same way as a horizontal or vertical box, except that you can fill it beyond its on-screen size, and you'll get given a scroll bar so that you can scroll up and down through your content. And the scroll box by default is vertical, and if I just stack some borders in here again they come in very small because the border doesn't have a defined size by default. There we go, that's given them a slightly larger desired size there. So you can see if I copied these, once they've used up the available screen space, a scroll bar will appear and widgets will start getting hidden out of bounds, and then at runtime we'd be able to scroll up and down between these. So again, top to bottom, vertical layout, very nice and simple. Of our grid panels, there are two more that I'm going to cover, being the size box and the scale box, but they're a little different, so we're going to do them next. For them, we really need to have a root widget to use them on to demonstrate their functions. So, the scale box makes sure that whatever you place inside it will maintain its aspect ratio correctly. So, no matter what shape I drag our scale box to, the image inside it will always remain square, or in the case of a non-square image, it will always size to its native aspect ratio. This is handy for scaling, as you can anchor one of these in the correct position. Make sure, say that we wanted it to stick in the top left, and no matter what size your screen was scaled to, your image would still always be square and it would always be placed in the top left. The size box is slightly different. The size box allows us to place a number of overrides on the size of whatever's inside it, regardless of what its anchors or other sizing behavior might already be set up as. So say we want to do a width override of 100. And then a height override of 200. If we then drop this size box into any container that is not a canvas, size boxes will not work when they're parented directly to a canvas. So I'm going to use this border. I'm just going to change the color of our borders so we can clearly see. And drop the size box inside. So we've maybe made that a little big. And of course, we need it to not be set to fill its container, but to be anchored somewhere within it at its native size. Now, if I change the override values, the item inside the size box will be forced to the sizes that I have defined in the size box data. These two can also be combined so that placing a size box inside a scale box can allow you to specify the aspect ratio of what you want to place inside. So now, regardless of how I stretch this, it will be scaled at 3:1. These two can be combined with different anchoring behaviors on a canvas or inside another container in order to custom scale elements that you don't want to stretch. That pretty much covers most of the important panel behaviors. So I'm going to stop there and come back in our next video.